In lesson number 3, we're going to talk about permutations with restrictions and permutations with repetitions. So let's look at a few examples of what these types of questions are going to look like. So in how many ways can all the letters of the word oranges be arranged if there are no restrictions? So there's no restrictions, so what we need to do is see, well, how many ways can the word orange and the letters of the word orange be arranged? Well, if I have 1, 2, 3, 4, 5, 6, 7 letters, that's just going to be 7 permutation. And 7 permutation, if we type that into our calculators, let's go 7 math. Option 4 is 5,040. Okay, now let's see if I have the first letter must be an N. Okay, if the first letter is an N, then that means that there are 6 other letters in the word orange. So that would be 6 permutation. If we type that into our calculators, 6 permutation, that would give us 720. Now, the vowels must be together in the order O, A, and E. So O, A, and E must be together, and that would be the first restriction, which means that if I have O, A, and E, out of 7, I'm going to have 1, 2, 3, 4 letters left, since there's 7 letters altogether, but these are taking the first space or the second. Then these they essentially count as one of the letters. So that would be 1, 2, 3, 4, 5, or 5 permutation. 5 times 4 times 3 times 2 times 1 would give us 120. Now, here's what we have. We have a permutation with a combination and a permutation with a restriction. All right, and sorry, a permutation. Both of them have restrictions in this case. Now, how many of the arrangements of the letter of the word brains are the vowels together? So if I look at brains, A and I, the A and the I have to be together. Now, if it's A and I, they can be together in AI, or they can be together as IA. And if it's like that, let's just think about AI. Then I'd be left with B, R, N, and S. Or I could have it the other way around, where I have I and A together, and then B, R, N, S. So essentially, with it together, that's 1, 2, 3, 4, 5 different ways we could arrange it, which would be 5 permutations, which is 120. It's the same thing, but I and A is switched around, which does make a difference, 120. Now, 5 permutation times 2, or 5 permutation plus 5 permutation, there's 120 ways to arrange it with A first and then I, or 120 ways to arrange it with I first then A. And so 120 plus 120 is going to give us 240. Now, we'll skip this one for now. Let's move over to class example number 4, just so this video doesn't end up being too long. But in how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? Okay, well, we have 7 people altogether, so 1, 2, 3, 4, 5, 6, 7, and they have to sit in such a way that they're not sitting beside the same gender. All right, so there's 4 boys and 3 girls. Now, since they can't sit beside someone of the same gender, they have to sit boy, girl, boy, girl, boy, girl, boy. Now, the boys can sit. They have to sit every other, and as do the girls. Now, it's going to have to be this way. We have to start with a boy and end with a boy, because if we start with a girl and end with something like this, I'll just show you 1, 2, 3, 4, 5, 6, 7. So girl, 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 boy, 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 boy. Now we have 2 boys sitting together, which won't actually work. All right, so the boys there's only 4 ways the boys can sit, and, or sorry, 4 permutation the boys can sit. So 4 permutation for the boys. And for the girls, it's going to be 3 permutation for the girls. So both the boys and girls together, we are going to have boys and girls. This would equal 4 permutation times 3 permutation, which would equal 24, which is 4 permutation times 3 permutation, which is 6, which is 144. Now 6 actors and 8 actresses are available for play with 4 male roles and 3 female roles. How many different cast lists are available? Now this is when we have to use what we used in the last unit when we introduced the number of permutations as NPR, or sorry, lowercase r, NPR. All right. Now, what this looks like is then if I have 6 actors and 8 actresses, then we're going to have, and we have 4 male roles and 3 female roles. So 8 actresses with 3 female roles, 6 actors with 4 male roles. How many different cast lists are available? This becomes 6P4. So we have 6 actors, 4 male roles, times 8P3, which is equal to math. Oh, and I'm going to go 6 first and then math. Option 2 and 4, so I have 360. And 8 math, 2, 3, 336 times 336 is equal to 120,960. Those are all the different cast lists that can be made with this amount of people. All right, now let's look at permutations with repetitions. This is something you could read yourself. I'm not going to spend the video reading it for you, but essentially in this section we're going to examine different scenarios where we could have a repetition of repetitive letters. So if I have, for example, to examine this scenario, consider the following 4-letter permutations of a word without repetitive letters, so rows. If you look at rows, there's only so many ways you can organize these letters because you have R, O, S, E. All these 4 letters are different. But if I have a word like Ross, there's still a lot of different ways we can arrange them. But notice that the S's are essentially, well, they are the same letter, but I could label that as S1 and S2, in which case we could have different arrangements of those letters. All right, and so that's what we're going to be looking at here. Now, when that happens, we use the following formula. So N permutation divided by A permutation, B permutation, C permutation. Now, let's see how we actually apply this. So find the number of permutations of the letters of the word Vancouver. Now, in Vancouver, we have 2 V's, and all the other letters are different. So out of the total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And so that would be our value of N. So if I have N permutation divided by A permutation, B permutation, C permutation, what this is going to look like is 9 permutation divided by, well, I have 2 V's, and so we would say 2 permutation. 9 permutation divided by 2 permutation. So if we wanted to put this in our calculator, brackets are going to be our best friend. So 9 permutation divided by 2 permutation. I get 181,440. Now let's look at this next example. We're still using the same formula, N permutation, A, B, C. Now, out of all of these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So 12 permutation divided by, well, let's see how many times I have a repeat. I have 2 M's, so 1, 2, that would be 2 permutation. And I have, how many A's do I have? I have 1, 2, 3 A's, 3 permutation. And I have 2 T's, 2 permutation. And everything else is only appearing once. And so this problem becomes 12 permutation divided by, and here it might be wise to use double brackets, 2 permutation, which is 2 times 1 or 2, 2 times 6 times 2, which is 19,958,400. All right, so this is how we deal with permutations with repetitions. So before we were looking at permutations with restrictions, now we're looking at permutations with repetitions. All right, let's look at this next problem. So Brett bought a carton containing 10 mini boxes of cereal. There are 3 boxes of cornflakes. So we might want to make a list of what we have. So we'll see 3 CF. We have 2 boxes of Rice Krispies. We have 1 box of Cocoa Puffs. And then we have 1 box of Shreddies. And the remainder are going to be Raisin Bran. So if we have 10 mini boxes, we have 3, 2, we have 5, 6, 7, and then the other 3 are Raisin Bran. So 3 Raisin Bran. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning. How many different orders are possible if on the first morning he has a Raisin Bran? Okay, so right away, this puts a restriction on our problem. So we know that on the first day, he's always going to eat Raisin Bran. So now what we have is we eliminate one of the Raisin Brans, and so we actually only have 2 Raisin Brans to choose from. And that also changes our total. So instead of 10, we're now working with a total of 9 after the first day. So I have 1, 2, 4, 6, 9. So that means that we're going to have 9 permutation, and we are going to divide it by 3, 2, and 2. And you know what? I can ignore the 1s because 1 permutation would just be 1, right? There's no way we can really organize that. And so I don't have to actually include that in my calculation. So what we're going to be left with is 9 permutation divided by 6. So 3 permutation is 6 times 2 times 2 permutation. And there are going to be 15,120 different orders possible. Now, last example, let's look at this example 8. Paul and Catherine are considering the following problem. Find the number of routes from A to B if routes must always move closer to B. So every time we move away from A, we have to be moving closer to B. So I can't be like bam, bam, bam. So I can't go this way, down, and then back. I always have to move closer to B. So I can't backtrack towards A. So Paul arrived at the correct answer by tracing 10 routes on the grid. Catherine developed a quicker method. So what Paul did, it looks like that he actually counted and did all the routes by tracing them on the grid. But what Catherine did, she realized that traveling from A to B involves moving 3 units east, so 1, 2, 3, and 2 units south, 1, 2. Now the answer to the problem is the number of ways in which this can be done, so 3 E's and 2 S's in any order. Solve the problem using Catherine's approach. Well, in total, there's 1, 2, 3, 4, 5 different directions, so 5 permutation, and I have 3 E's and 2 S's, so 3 E and 2 S's, which would equal 5 permutations, so 120 divided by 6 times 2, or 120 divided by 12, which is equal to 10 different roots. Now, that is way quicker than just going through and counting or tracing each one, right? Because you have to go, okay, well, this is one root here. That's one root. This would be another root. This is another root. This is another root. That's another, or that's another root, right? Like that would take way too long. So permutations are your best friend.